For the 7th straight year, a group of Penn State meteorology students led by an experienced guide is spending 10 days in May in the central states chasing severe thunderstorms. And one area they will surely visit during their trip is the western part of the southern plains because of a late spring and early summer feature called the dry line. Now, to find the dry line, we use the dew point, which is proportional to the amount of water vapor in the air. We head to the western high plains where this time of year, dry, warm air from the southwest, what we call continental tropical air, typically meets up with warm, moist air coming in from the Gulf of Mexico, maritime tropical air. The dry line is the boundary between these two air masses that differ significantly in moisture content, and it's often the trigger for severe thunderstorms. The latest round started Saturday evening. The Storm Prediction Center issued this graphic highlighting the potential for large hail and a brief tornado in this area. And here's what it looked like from space. Visible imagery on the left, colorized infrared on the right, 1 image per minute. Dry line thunderstorms sometimes develop as widely separated individual storms, what we call discrete supercells. That's what happened here. Those storms weakened at night, but by late Sunday afternoon, once again, SPC forecasters highlighted pretty much the same area for severe thunderstorms. And by the way, the brown line with brown semicircles that you see here, snaking from north to south, that's the official Weather Service map symbol for a dry line. On Sunday, thunderstorms were more numerous and less discrete, also developing farther north into the panhandle of Oklahoma and western Kansas, as seen on this true color visible image on the left. In the colorized infrared on the right, the highest cloud tops, indicating the tallest and typically most powerful thunderstorms, are in maroon. One cluster near Lubbock, Texas was particularly interesting. Here's high-resolution imagery every 30 seconds, focusing on what eventually became a single huge supercell. The highly textured, pulsing, bubbling nature of the clouds indicative of very rapidly rising air. And as the sun set in the west, you could see the dark shadows cast by the tallest parts of the clouds. Doppler radar imagery from Lubbock showed a complicated structure with one primary center of counterclockwise rotation eventually winning out. The large blob of high reflectivity indicative of very heavy rain and some hail with a curly-Q appendage on the southwest side, the hook echo, indicating where a tornado was likely to form. And in this case, here was the ground truth. If not for the modern wind turbines, this could have been right out of The Wizard of Oz. Storm chasers with Weather Nation intercepted this twister near Tahoka, Texas, about 25 miles south of Lubbock. Fortunately, the tornado stayed in mostly open country and caused no injuries. And the dry line stayed active Monday and Tuesday as well. That supercell on the right from yesterday was producing a tornado at the time of the imagery. Today, the classroom for our storm-chasing students will still be in Texas. Tomorrow, it moves a bit farther east into the lower Mississippi River Valley. Stay tuned. Our extended forecast is next.